Okay, we're going to learn how to solve a matrix, and we're going to start with a system with only two equations that's a little bit simpler so that we can learn the process. First of all, before we start, warning, you will mess up, okay? It's nearly impossible to get these right the first couple times you do them because there's so much room for error. So be very careful on your arithmetic and check your work. Now, the process I'm going to use is always the same. First, we're going to get a 1 in a desired location, okay? That leading entry we need for row echelon form. Now, how are we going to get a 1? We have two options. We can interchange or we can multiply, meaning we're allowed to switch rows in order to get a 1, or we're allowed to multiply a row by a number in order to get a 1. 2, we're going to get zeros where we need them. Okay, and in order to do this, we're going to do the replacement step, which, if you remember, was adding to one row a multiple of another row. And then we are going to repeat this process as often as we need to end up with row echelon form. So here's our system. Our first step is to write the augmented matrix. So the numbers from the first equation go across the first row, and then the numbers from the second equation. Now, when I say get a 1, ideally we want 1s down what we call the diagonal. Okay? The main diagonal from the upper left to the bottom right of the coefficient part. So first I want a 1 here, and good for me, I already have a 1 there. Okay? So now I move on to step 2, which is that everything below that 1 must be made 0. So I want to get rid of this 2. Now, I know already that to get rid of a number and make it a 0, we're going to use replacement. So I'm going to replace row 2 with row 2 plus some multiple of row 1. So 2 plus some number times this 1 should equal 0. If we think about it a little bit, we decide that 2 plus negative 2 is 0. So I'm going to need to multiply this row by negative 2, and then when I add them, they will cancel. Okay, so I do that. My first row has not changed. Okay, but for my second, I'm doing 2 minus 2 times 1 is 0. 1 minus 2 times 2 is 1 minus 4, or negative 3. 8 minus 2 times 7 is 8 minus 14, which is negative 6. And I got the 0 where I wanted it. Now, I have a 1 here. The next goal is to get a 1 there. Okay? And I have two options for a 1. I could switch rows. Okay? Only that will mess up the 0 that I already so nicely did. Or I can multiply this whole row by a number that will turn it into a 1. And the number I'm going to multiply it by is minus a third. So I'm going to do minus a third times row 2, because minus a third times that minus 3 is going to give me 1. Okay, my first row hasn't changed. My second row becomes 1, 2. And I have the 1s where I want them, the 0s underneath the 1s, and notice that the 1s go down the diagonal as we move right. These are the three conditions of row echelon form. Okay, so this does not mean that I'm done. It just means that I've done the matrix part. Now, I'm going to turn this final matrix back into a system of equations. This says 1 times x plus 2 times y equals 7. And this says 1 times y equals 2, which means I already know one part of my answer, and now I just have to get the second part, and I can do that by plugging it back into the equation above it. So x plus twice 2 must equal 7. This is x plus 4 equals 7, or x equals 3, and I have my answer for this system. Okay. Now, we only were able to do the process about once because the system was so small to start with. So now we're going to do a bigger system. Okay. 3x minus 2y plus z equals 15. Minus x plus y plus 2z is minus 10. X minus y minus 4z is 14. This is my new system. I'm going to use the same method to solve it. So first, I turn it into an augmented system by reading the numbers of each equation across. Now, I want a 1 up here. I have two options. I could divide this whole row by 3, only I don't like that option because it gives me fractions. Or I can simply switch the first row and the third row that already has a 1. So I'm going to do row 1 and row 3 switching. Okay, now I have my 1. I need to get zeros underneath it. And I can do these in the same step because they don't interfere with each other. To get a 0 here, I'm going to replace row 2 with row 2 plus row 1, because negative 1 plus 1 will give me the 0. Okay. So my first row is not going to change. My second row becomes 0, 0, minus 2, 4. And my third row I'm going to fix in the same step. So I'm going to go back over here and say row 3 is going to be replaced with row 3 minus 3r1. Because 3 minus 3 times 1 will give me the 0 that I want there. Okay. So I end up with 0. Negative 2 plus 3 is 1. 1 plus 12 is 13. Okay. And 15 minus 3 times 14 is negative 27. Okay. All right, now my next goal is to get a 1 here. And no matter what I multiply by, I cannot turn a 0 into a 1. So instead, I'm going to switch the second row and the third row, since it already has a 1 there. Okay. So this is what I get. Notice, I also then get the 0 underneath it that I would have needed. So next, I want to get a 1 right here. And the easiest way to do that is to simply divide the whole row by negative 2, alternately multiplying it by minus a half. Okay. I'm going to go up here because we're running out of room. So my new system is this. Now, if I turn these back into equations, I will be able to solve for all my variables. First of all, I see that I already know what z is. Okay. Since I know z, I'm going to plug it back in to solve for y. So this is y equals negative 1. Since I know z and y, I'm going to plug them back in to solve for x. So this is x plus 1 plus 8 equals 14. X plus 9 equals 14. So x equals 5. And thus I was able to solve my system.